Welcome to another video as part of the Pavilion video series. This is SQL Server Latency Part 2 of 2, Latency for Improved High Availability. The key point here is don't let slow storage hurt the performance of your database's high availability. I'm Costa Hasapopoulos, the Chief Field Technology Officer for Pavilion Data. I'll be joined by David Klee, the founder of Heraflux Technologies, who will be our main speaker for the day. So in the spirit of that concept of not letting slow storage hurt the performance of your database high availability, in this video, we're going to talk about a few things that will address that particular challenge, including database transactions, transaction hardening, how availability groups can be optimized to support that, as well as talk about transaction commit time. So before we get into the presentation and an introduction of David, let's talk about Pavilion and how Pavilion unleashes the power of Windows and SQL Server. Of course, we work well for every single workload, but if you have super high bandwidth per host needs with ultra low latency, this is where we really shine. Whether that's large or small block sizes, whether that's read or write. Specifically, that relates to SQL Server. So that Pavilion platform that has impressive IOPS and the millions of IOPS and the impressive throughput, but what is most impressive is that latency in the range of 100 microsecond read to 25 microsecond write latency. All of that packed into 4 rack units and over 2 petabytes of usable capacity. Whether you're leveraging that platform for a Windows environment running SQL Server on bare metal, leveraging NVMe-TCP or NVMe-RoCE, we have certified drivers from Windows to support both of those environments. What's really impressive, you can get similar or same performance of bare metal inside of VMware running SQL Server in Windows, leveraging VMware 7.0 and Pavilion support for NVMe-over-Fabrics RoCE for VMware 7.0. So whether it's bare metal on Windows for Windows or whether it's virtualized inside of VMware, incredible performance, but ultimately low latency, which drives incredible results for SQL Server. So our presenter today, I'm excited to introduce the founder of Heraflux Technologies and Sequilibrium Education, David Klee. David is an incredible performance tuner, enterprise DBA, and infrastructure architect, and self-proclaimed geek. David's expertise in SQL Server and VMware are the best I've seen. His ability to intersect the storage, the software, and the virtualized infrastructure or non-virtual infrastructure, and to tune the system to get the most out of SQL Server is incredibly impressive. So with that, I'll turn it over to you, David, and let's learn more about SQL Server.
Thank you very much, Costa. Let's talk about database transactions. As you know, every single thing that happens in a database in terms of data change has to be recorded. Well, the biggest thing for me is to understand how and where this transaction change or reading data seems to matter when it comes from disk. Well, database reads largely come from disk until they're needed more than once and they stay in memory. SQL Server has a very large memory pool. It's called a buffer pool, and it's essentially a storage read cache. So if data is being repetitively read, it's not that big of a deal as long as you have enough memory or the storage can keep up. But when you deal with database writes, this is the business process. This is that change to that history of that object that has to be written to disk. Well, there's a lot of examples for this. It could be a new order gets placed into your ERP system, or you've shipped a product and you want to mark the shipping number. Or a patient was admitted to the hospital and you kind of want to keep track of them. Or money was deposited into your account. All of these are absolutely critical that you make sure that you get this change to disk as fast as possible. Every single change that happens to these database objects, including updates, deletes, and inserts, absolutely have to be recorded to disk to make sure that this transaction is recorded. It's absolutely critical. We can't have data loss in the event that anything big happens to these systems. So as part of the ACID properties of a relational database engine, we have to harden this transaction to disk before that transaction to disk, that change operation, is considered completed. Now, how do we do this? The database is made up of multiple components. So if you take a logical database, usually at a minimum, you're going to find a data file, or in this case, MDF, and you have secondary data files. They're usually suffixed NDF. And then there's a transaction log file, or LDF. This transaction log file, it's not a normal log file. This is quite literally the ledger of everything that is changing inside this database. That's a big deal. So when you place a new order into the system and you go and update this record, the database goes, I've got it. Let's make this change. It write ahead logs, meaning it's going to write to the transaction log first. As soon as the change gets hardened there, then the data file is updated with this transaction. This is absolutely important because the speed at which we can make these changes to disk matters. Business is being held back if we can't do this quick enough. At that point, this thing is now considered done and life is good. If we can do this quickly, life is awesome. Now, the interesting thing here is that every single change that happens, it has to go through this whole process every single time. And it seems complicated, but realistically, this is the speed of the business operation. We have to get this done quickly, or else the business is being held back. So, how fast can we commit this? That's what really matters to true DBAs out there. And for these really large operations, this separates the systems that can scale from the ones that can't. Okay, now we need to figure out how a database availability architecture is actually going to play into this, and why does storage really matter for it? So we're going to take Microsoft's flagship availability option. These are called availability groups. And essentially call them AGs, not AOAGs or AAGs or always on. Always on is a marketing feature. This is an availability group. From a virtual machine perspective, your VM admins really are going to treat this like regular virtual machines, but with sensitive networking needs. A little bit of TLC. It essentially takes really the best of the features between a failover cluster instance and a database mirroring architecture and combines them to make one of the best availability architectures that I'm aware of. So take your SAN, take a hypervisor, carve up a couple of data stores. Now, it could be the same one, they could be different ones. If you're truly paranoid about HA, they might actually be separate SANs. Build out a couple of virtual machines. So we're going to call them SQL A and SQL B. Do what you normally do. Install the database engine, in this case SQL Server, hopefully 2019. Get some databases on there, put them on different virtual disks. All the normal best practices apply here. They can be on the same data store for now. We'll let the performance characteristics dictate that. And then we're going to set this up in a highly available architecture with a second full SQL Server. Set them up identically. They're going to be receiving a copy of the data from the primary SQL A here. At this point, we're going to define a cluster-based availability group. So create a Windows Server failover cluster between the two of these. They don't have to have shared storage. So a lot of the historical complication that came along with this isn't there. You have a cluster VIP, a virtual IP address, that allows you to centrally manage and deal with that. But usually we just push that off to the side. Create a file share witness so that we have quorum for this 2-replica availability group. Now, create the availability group itself. It's essentially a logical container of one or more databases that are now governed by the same set of availability rules. You can do synchronous, you can do asynchronous if you're doing disaster recovery or reporting, things like that. But now all of the databases in this availability group are governed by this. So they're all synchronously replicating to the second replica here. Add a listener, and this is what our applications are going to connect to. At this point, this is now fully highly available. Where this starts to matter from a latency perspective is that because of this write-ahead logging, and the need to do this on the secondary first, we have basically a double hop here. So make a query that's changing data. Okay, no problem. This database agent that's acting as primary is going to send this over to the secondary replica in order for a remote commit. Once it's done, it acknowledges that it's done, and then the primary machine is able to go commit to disk, and then that transaction is considered completed. No problem. Okay, take a normal standalone SQL Server. Nothing too fancy here. So let's commit a transaction from the application server. So our normal storage response time, nothing fancy. We have to deal with how fast it's going to take to actually get to disk into the transaction log file and then be committed into the data file and then consider it done. So let's just say we're dealing with okay storage. So 5,000 microseconds, 5 milliseconds. 10 years ago, that was considered okay. The entire runtime, 5 milliseconds, it's there. It's not great, but it's there. Okay, now add the availability group into our environment. We first have to deal with how long it's going to take to copy the command and maybe the payload from A to B. So let's just say 100 microseconds. We're being optimistic here. Now we have to commit it on SQL B. So yeah, let's deal with a normal storage device. You're looking at, 5 milliseconds. Not that bad individually. Now acknowledge back to A that we're completed, so another 100 microseconds, and then commit to A, same 5 milliseconds. Add them up. The entire runtime there is 10.2 milliseconds. It may not seem like a lot, but let's say you're trying to do a bulk insert of 1 million records, that adds up pretty fast. Now handle your availability group architecture, the commit time related to storage. Well, we've got to get this latency as low as humanly possible. What if we could actually go from, let's say, 5 milliseconds to 100 microseconds? What does that do to the speed of that overall operation to make sure it's hardened in both locations? That's a dramatic difference. And now, deal with RoCE Ethernet, and we're dealing with even faster server communication. So the act of getting the payload to B and then the acknowledgement back to A get even quicker. And then get the lowest possible latency storage, because guess what? If we can harden there, everything else gets better. So it can improve the availability group performance considerably, and we're talking dramatic performance gains. Maintain that high availability architecture. These machines are absolutely critical, and you can't lose data. So maintain that, but make sure it's not slowing you down. Everybody wins if you do this properly from the bottom up. In all of my years of SQL Server engineering, storage latency matters more than anything else. This is where I see Pavilion fitting in. It scales, the NVMe media, the PCI switch architecture, the multiple active controllers, all of it matters. Costa's going to show some performance numbers that you really might not believe, but take it from me. I'm an independent consultant designing some of the largest systems in the world. Thank you. This thing works. I love the opportunity to share absolutely nerdy details about SQL Server data platforms. Back to you, Costa.
Thank you, David. Great insights as always. As we summarize this video, let's bring it back to something that's really core to SQL Server, latency. So as we look at a Pavilion storage array, it's always sub-microsecond latency, whether that's bare metal or VMware, whether that's read or that's write. Impressive latency drives lots of things upstream to SQL Server that are all good. It pushes the bottleneck from the storage to somewhere else inside a SQL Server ecosystem. So we have demonstrated through this table that is a disk speed on Windows with a single Windows host and a single NIC. Some very impressive latency, whether that's Windows bare metal, the first two columns, Windows TCP and Windows RDMA, the read, and then the first two columns on the right. But what's equally impressive is the latency by taking that same ecosystem and put it inside of VMware. Similar or same latency, or in some cases better depending on the protocol than bare metal. So as we see, latency is key to SQL Server, and Pavilion can deliver impressive latency. bare metal, or inside a virtualized VMware ecosystem. Thank you so much for spending time today with us, learning more about SQL Server and how to optimize the SQL Server ecosystem to get the most out of your investment. Special thanks to David Klee, our SQL Server extraordinaire. We appreciate all the partnership and all your insights you've given us today. If you want to learn more, come check out our other videos at www.pavilion.io or reach out to us via email at info@pavilion.io, or of course you can always call us on the phone. We'd love to talk to you about how Pavilion can help you optimize your SQL Server environment and get more out of your investment.